The Voice of America presents Forum, the Arts and Sciences in Mid-Century America. Today, for the second in a series of 17 lectures on the philosophy of science, Forum brings you Professor Isaac Levi of the Department of Philosophy, City College of New York. The philosophy of science lectures have been planned and coordinated by Professor Sidney Morgenbesser of Columbia University. Today, Professor Levi will discuss utility and acceptance of hypotheses. Professor Levi received his B.A. degree from New York University and his M.A. and Ph.D. degrees from Columbia University. He taught at Western Reserve University from 1957 until 1962. In 1962, he joined the faculty of the City College of New York as an assistant professor. Professor Levi has published many articles in his field and 2 translations, The Old and the New Logic and the Theory of Objects. Professor Levi.
We are apt to think of the scientist as someone quite different from the policymaker. Unlike the man of action, the scientist is concerned not with what we ought to do, but with what we ought to believe. His aim is to make true predictions, to describe the past and present as accurately as he can, and to explain what he predicts and describes in terms of general laws and theories. Moreover, in his quest for the truth, the scientist must overcome his personal prejudices. Even his moral commitments and the interests of the society or group which he serves should not interfere with his conclusions. Unlike the policymaker, the scientist is supposed to observe neutrality on questions of value. This does not mean that he must be temperamentally cold-blooded, nor does it imply that he must avoid value commitments in determining what problems he will select for study. But once he has chosen a problem, value neutrality requires that he determine which of the possible answers is correct on the evidence available to him, independently of his value commitments. Consider an economic advisor to President Kennedy. As a scientist, he is obligated to study the consequences of various types of economic policy and to reach conclusions without regard for his values, for Kennedy's values, or for the interests of the American people. How can the results he obtains be applied to practical problems, such as, for example, whether to reduce taxes? The obvious and classical answer to this question is that when choosing between alternative courses of action, for example, a tax cut and increased government spending, the policymaker must, on the one hand, know what his goals and values are, and, on the other hand, know how the consequences of adopting one or the other of the alternative policies implement or frustrate the attainment of these goals. Furnishing the goals and values is not within the province of the scientist as disinterested investigator of the truth. He does, however, play a legitimate role in determining the consequences of the various policies. This he can do in the course of his disinterested quest for the truth. Thus, although the aim of the scientist, as scientist, is to seek the truth, the conclusions which he reaches in his theoretical inquiries often furnish information about consequences of vital importance to the decision maker. All of this seems too obvious to be worth discussing. But closer scrutiny indicates certain difficulties. Notice that the scientist cannot guarantee to the policymaker that his predictions will be borne out. Nothing is certain, not even death and taxes. The evidence on which conclusions in the natural and social sciences are based can at best confirm these conclusions to a degree. They are more or less probable. The traditional account assumes that the policymaker relies on the predictions which the scientist accepts as true. This is wrong. A rational decision maker relies not on these predictions, but on the probabilities that these predictions are correct. Consider a man suffering from an ailment for which either a drug therapy or surgery is recommended. The drug therapy offers a 50-50 chance of cure, whereas surgery offers a 70% chance of success. Assume also that failure in both cases does not change the patient's condition appreciably. The physician, like Kennedy's economist, must be both a scientist and a decision maker. As a decision maker, he must take into account his values and the interests of his patient. In this, the traditional account is correct. However, the classical view is mistaken in contending that the physician as scientist contributes to the decision by making predictions as to what will happen if either of the therapies is adopted. Making a prediction is tantamount to accepting a certain statement as true. In the circumstances just described, no responsible physician could make a prediction as to the outcome of the drug therapy or surgery. At best, he could give some indication of the probabilities of the truth of various predictions. Consequently, as a decision maker, the physician cannot rely on predictions as to what will happen, but only on the probabilities that it will happen. Suppose the chance of cure by surgery was not 70%, but 98%, and that failure of surgery resulted in death. As a scientist interested in the truth, the physician might feel warranted in predicting success when the operation is to be performed. Nonetheless, as policymaker, he might recommend drug therapy. For the seriousness of failure with the drug therapy is so much less than in the case of surgery. Thus, even when the scientist can make predictions, these predictions are irrelevant to deciding on a course of action. What is relevant is the degree to which the evidence supports the prediction. When a human life is at stake, our ethical commitments often require higher probabilities for action than for belief. The traditional view is indeed correct in distinguishing between the practical and theoretical aims of science, but it is mistaken in holding that the results of furthering the theoretical aims contribute to the realization of practical goals. What the scientist contributes to policymaking is found not in the conclusions of his inquiries, but in the probabilities on which these conclusions are based. Although men have recognized for a long time that all decision-making involves risks, only in recent years have there been widespread sustained attempts to formulate in a systematic way principles of rational decision-making, which take into account probabilities of success and failure, as well as the values or utilities of the decision-maker. Jeremy Bentham, at the end of the 18th century, had already suggested that a rational decision-maker should maximize utility, and that in so doing he should take into account probabilities. But utility for Bentham was a measure of pleasures and pains. Not only have there been serious difficulties with assigning numerical values to pleasures and pains, but it is at least debatable whether men ought to aim at maximizing pleasure and minimizing pain as their sole objective. The distinguished mathematician John von Neumann has shown how the notion of utility might be extricated from these difficulties by constructing a notion of utility that may be used to measure value, where value involves moral and political considerations as well as personal preferences, pains, pleasures, and so on. Together with his economist colleague Oscar Morgenstern, von Neumann developed the foundations of a mathematical theory of games and indicated how it might be applied to economic decisions. Statisticians such as Jerzy Neyman, Abraham Wald, and Leonard Savage have attempted to recast the central questions of statistics as problems in decision-making. R.B. Braithwaite, the British philosopher, has argued for the relevance of game theory to questions in ethics. These writers and many other statisticians, economists, sociologists, and philosophers, all of whom have some interest in rational action, have contributed to a growing body of literature on game and decision theory. Much of this material is covered in the excellent critical survey, Games and Decisions, by D. Luce and H. Rafa. We cannot recount the results contributed by decision theory to the understanding of rational policymaking here. However, one elementary idea which underlies much of the work in this field will prove important in our subsequent discussion. Recall once more the decision facing the doctor who has a choice between surgery and drug therapy when treating a disease. How is he to decide between them? Should he take into account only the probability of successful cure and opt for the policy which promises a greater chance of success? If the consequences of failure are no more disastrous when surgery is selected than when drugs are, this would be reasonable. But a failure of surgery is fatal, whereas failure of the drug therapy is not. The probability of success via surgery ought to be much higher than the probability of success through drugs before surgery is chosen. Making a decision is like gambling, although it is much less frivolous. Should the losses to be sustained prove to be very high, the chances of success must be high before a rational man will take the risk. Let us assume, for the sake of the argument, that decision theory can help us understand in detail how the probabilities furnished by the scientist contribute to deciding how to act. We must now ask how these probabilities help promote the scientist's own attempt to replace doubt by true belief. Probabilities, after all, are just as important to the scientist as they are to the policymaker. Like the policymaker, who takes a risk that his actions may prove unsuccessful in furthering his goals, the scientist who accepts a certain answer as a true answer to a given question takes a risk that his answer is in error. Hence, as in the case of decision-making, there is a need for criteria for determining how high the probability of success and how low the probability of error must be before a scientist can accept a certain answer as true. Many critics have argued that this problem cannot be solved unless the alleged value neutrality of the scientist is abandoned. According to these critics, the only way in which minimum probabilities for accepting propositions as true can be determined is by taking into account the values or utilities of the investigator or of the community whose interests he serves. Like the decision maker, the scientist must take into account the seriousness of mistakes in determining minimum probabilities. This argument against value neutrality will not stand by itself. It rests on a misconception of what scientific value neutrality entails. When a person decides to engage in scientific activity, he perforce commits himself to certain values. He obligates himself never to accept contradictions as true, never to accept assertions from uncertified authorities, and in general to conform to certain principles governing when it is and when it is not legitimate to accept propositions on the basis of given evidence. A commitment to a scientific way of doing things is a value commitment, which no reasonable interpretation of value neutrality can prohibit. But once the scientist has committed himself to drawing conclusions in accordance with the canons of scientific inquiry, he can be forbidden to take into account any other value commitments he might have. This is the prohibition implied by scientific value neutrality. Thus, although we do need to decide on minimum probabilities for accepting scientific conclusions, these minima may be determined by the canons of scientific inquiry in a standard way which the scientist is not permitted to alter to suit his own tastes or values. This situation would be compatible with value neutrality. Throughout this discussion, we have assumed that whatever contribution can be made by science to decision-making, it does have a concern of its own, to wit, seeking the truth. This view has been subject to serious doubt on the basis of considerations deriving from recent theories of statistical method. According to views developed by several contemporary writers on statistical theory, the fundamental problem of statistics is what Neyman calls inductive behavior. A manufacturer's decision to market a given product might depend in part on whether the quality of the product is sufficiently high. If too many defectives are found in a sample subject to inspection, he might withhold the product. The effectiveness of drugs and vaccines, educational programs, and so on, are frequently tested through the use of techniques of statistical inference. In all these cases, and many more, the aim of statistical method is to provide information concerning probabilities, which will be relevant to rational action in the face of uncertainty, where the seriousness of error is important. Statistics, according to this conception, is nothing but a special branch of decision theory. But here is where a difficulty arises. Those very same techniques which are designed by their authors to handle decisions how to act in the face of uncertainty are also employed in deciding what to believe. In genetics, sociology, and psychology, statistical methods are used to test the truth of scientific hypotheses. Thus, a psychologist may be interested in discovering whether achievements on certain intelligence tests are correlated with specific mental disorders. Not, so it would seem, in order to undertake any program of action, but solely in an effort to understand mental disorders and performance on intelligence tests. Yet, according to what we said before, statistical theory requires that we take into consideration the seriousness of mistakes. This makes sense when we apply statistical theory to inductive behavior, that is, to deciding how to act. Does it make any sense when statistical theory is applied to the psychologist's problem, which involves inductive inference, that is, deciding what to believe? Perhaps the answer is that there are two different types of statistical theory, one for inductive behavior and one for inductive inference. This answer will not do. The statistical methods designed for decision-making are also allegedly appropriate in situations which seem to call for accepting or rejecting propositions. Indeed, some of these methods, for example tests of significance, are actually applied to problems of inductive inference as well as to situations involving inductive behavior. How are we to justify the extrapolation from deciding how to act to deciding what to believe? The answer given by many authors takes one of two forms, both of which involve a radical rejection of the conception of science which we have been discussing. According to one formulation, the behavioralist view, when a scientist accepts a conclusion as true, he is doing nothing more than acting or being prepared to act as if the proposition were true relative to some practical aim. Thus, to accept as true the claim that the Sabin vaccine will prevent and not spread polio is tantamount to being prepared to use it in mass inoculation programs. According to behavioralism, scientists have no special theoretical objectives. The aims of their inquiries are the aims of the policymaker. Indeed, the scientist is a policymaker. According to a slightly different view, the scientist does not accept or reject propositions at all. He merely indicates how well the available evidence confirms or disconfirms hypotheses. His activity is important because it furnishes the policymaker with probabilities relevant to rational decision. But he has no special theoretical objectives of his own. In sum, the scientist is viewed neither as a man in search for the truth, nor as a decision maker, but as a guidance counselor. The guidance counselor and behavioralist conceptions of science, which number among their supporters philosophers of the eminence of Rudolf Carnap and R.B. Braithwaite, agree on one important point. Whether scientists do accept or reject hypotheses or not, they do so only in a sense equivalent to acting or being prepared to act relative to practical objectives. Consequently, inductive inference is inductive behavior. There is no need, therefore, to provide a rationale for applications of statistical methods designed for decision-making to cases where we want to decide what to believe. For deciding what to believe is equivalent to deciding how to act. The reduction of the theoretical aims of science to practical aims is not entirely new. In a way, this view has found expression in the writings of Marx, Bergson, James, Dewey, and others. What is novel is the defense of this reduction by an appeal to statistics and decision theory. We shall not have the opportunity to consider the many serious difficulties with a behavioralist or a guidance counselor conception of science. It will be sufficient to remember that when scientists consider the principle of parity, ask whether the universe is expanding or inquire whether Galileo did conduct the celebrated experiment at Pisa, they do not seem to have any practical objectives in mind. To be sure, believing, disbelieving, and doubting may be acts in some broad sense, but the act of believing or accepting a proposition as true, at least so it would seem, is not reducible to overt behavior, as the behavioralists suggest. And as the examples just cited illustrate, scientists do seem to accept and reject propositions counter to the guidance counselor view. However, even if we find the behavioralist and guidance counselor conceptions of science unacceptable, we are still faced with the problem these views attempt to solve. Namely, how is it possible to justify applying statistical procedures designed for rational decision-making to deciding what to believe? An idea of the sort of answer that may prove successful can be obtained from the following considerations. Even if believing is not the same as acting or being prepared to act, deciding what to believe may be sufficiently similar to deciding how to act to warrant using similar principles to characterize both rational action and rational belief, without identifying the two. The situation would be comparable to using similar mathematical formulae to characterize the forces due to electrical charge and due to gravity, even though electrical charge and gravitational mass are not the same. If such an analogy between deciding what to believe and deciding how to act can be found, then the desired justification of the application of statistical procedures in theoretically oriented inquiries would be obtained, without resort either to behavioralism or to the guidance counselor view. We cannot enter into a detailed exploration of the analogy here. However, the following points of similarity can be readily understood. First, when a person is engaged in a scientific inquiry and is considering several possible answers, the investigation terminates with his choosing one of the answers or suspending judgment. In this sense, a scientist chooses what to believe, just as a policymaker chooses how to act. Second, just as a rational policymaking is controlled by the goals of the policymaker, scientific inquiry aims at the realization of its own characteristic goals. These theoretical objectives may be characterized as the results of successful efforts to replace doubt by true belief. Third, just as the policymaker risks failing to attain his objective, so does the scientist, for the evidence available to him cannot guarantee the truth of his conclusions, but only make them more or less probable. Fourth, just as the goals of the decision-maker determine the value or utility to be assigned to the various possible consequences of his action, so the aims of scientific inquiry determine the epistemic utilities of the possible successes and failures of accepting various answers. Thus, a scientist will prefer a correct answer to an incorrect one, and in many instances, a scientist will prefer that one answer be true rather than another. This is especially so when the scientist is looking for explanations, which, according to a widely held view, are better if they are simple rather than complex. In such situations, the epistemic utility of accepting a true simple answer is higher than that of accepting a true complex answer. Similarly, the disutility of a false simple answer is lower than that of a false complex answer. Finally, we may say with some measure of plausibility that the scientist takes into account the scientific seriousness of error as determined by the epistemic disutility of accepting a false answer. Of course, we must remember in this connection one important difference between science and decision-making. Epistemic utilities and disutilities differ from practical ones in that they do not reflect the personal value commitments of the scientist or those of any group whose interests he serves, with one exception. They do involve a commitment to a scientific mode of inquiry. Thus, as we have noted before, the similarities between decision-making and the quest for truth do not preclude imposition of a value neutrality requirement on the scientist. The points of analogy between deciding how to act and deciding what to believe suggest that we may be able to justify applying the principles formulated by contemporary statistical decision theory not only to inductive behavior, but also to inductive inference. We cannot begin to consider all of the philosophical and technical problems which must be faced before a final verdict can be rendered on this suggestion. However, if the verdict should prove favorable, it would support a conception of the relation between theory and practice which differs not only from the behavioralism and guidance counselor positions, but also from the traditional view discussed at the beginning of our talk. This position holds, counter to the traditional view, that the results of a scientific quest for the truth do not, strictly speaking, contribute to the process of rational decision. The results are propositions which are accepted as true. As we have seen, the decision maker must rely not on the truth of these propositions, but on the probabilities of their truth. These probabilities are also needed by the scientist in deciding what to believe. He uses them as a tool, just as the decision maker does. The mistake of the guidance counselor view is the claim that the sole aim of science is to furnish these probabilities for use by the decision maker, whereas the mistake of the behavioralist view is in the assumption that the scientist is a decision maker. Science is neither the handmaiden of practice, nor is it identical with practice. It has its own objectives. Nevertheless, in the pursuit of truth, the scientist does produce, as a byproduct of his own efforts, information which the decision maker, be he ruler of state, industrialist, or average man, ignores only to his own detriment.
You have just heard a talk on Utility and Acceptance of Hypotheses by Professor Isaac Levi of the City College of New York. Professor Levi's lecture was the second in a series of 17 lectures on the philosophy of science, to be presented each week at this time. The Philosophy of Science series will be available in pamphlet form after the entire series has been broadcast. If you would like to receive copies of the lectures, write to the Forum Editor, Voice of America, Washington 25, D.C. And now, this is Morris Joyce, inviting you to join us again next week at this time when the Voice of America will present Forum, the Arts and Sciences in Mid-Century America.